This is Mr. Peterson. I teach math at Gardner Edgerton High School in Gardner, Kansas. And I want to teach you how to check expressions for equivalency, which is the second in a series on how to check algebra work with the Texas Instruments Ti84 calculator. Okay, to start us out, I have an example here from Algebra 1, just to get the concept going. And in this simple problem, the only thing we really are checking is collecting like terms and distributing. So this person distributed and then collected their like terms. And we want to check all three stages. We want to take the original problem and check stage 2, and then the final expression. So we're going to see if these expressions are equal. Now the concept is pretty simple. This is supposed to work for any legitimate replacement of x. We don't know what x is, but this is an expression that should be equal to this expression no matter what you choose for x. So I'm going to choose the one I usually use in class. I use a positive number. I don't like to use 0 or 1. You can actually use anything you want as long as it doesn't make any of the expressions undefined. So the one I always use in class is just an arbitrary number, 1.23, and I store that. Let me show you where the store key is. So touch that key as the value of x. And once I've done that, I hit enter, and now the calculator thinks it's using that number every time I type x. So I'm going to plant my finger right on that x key, and it's the non-dominant hand. I'm right-handed, so this left finger is just going to sit there on top of that X key, and its job is to hit that over and over again. So the left-hand side of the original here is 3 times 2x minus 5 plus 4x, and numerically, when we use 1.23 for x, we get this strange number, negative 2.7. Well, it's supposed to be equal over here, so now I just type the other one. And you get the same value. So I know that the second step there is done correctly. And finally, I type in 10x minus 15. And this problem, oops, let me try that correctly, 10x minus 15. I forgot to type the x. And this problem's been done correctly throughout the whole thing. I'm actually kind of glad I messed up there because you can see that you have to type things correctly for it to work. Okay, so the next stage here is to check a more complicated problem. And here's one that's got multiple lines of work. And after all the blood, sweat, and tears that went into this problem, you'd like to know that this answer is actually right. So you can go back to fix it if it's wrong, get the confidence you need, and so forth. So we're going to type 1.23. You can store anything you want, and store that in for x. Now, just to let you know that I really didn't have to do that, I'm going to hit clear and just hit the X, and you can see that it was already in there. And it doesn't lose it once you move on to the next problem. Okay, so here we go. Negative 2 times 3x plus 5 times 2x minus 1 plus 8x, and that gives this number here. And now we're going to type the final answer here and see if we've got all this work, if we succeeded, all the way down to the bottom. Negative 12x squared. Now you can hit the x key and you can also hit the squared key. But that requires me to take my index finger off that x key. If you just say x times x, that means x squared also. So now minus 6x plus 10, and the whole goal here is to do this quickly and efficiently. So all of that work is correct. And it's really nice to know that. It's also nice to know when you do it wrong so you can fix it before it's graded. Okay, here's another student that wasn't quite as careful doing the exact same problem. So we're going to troubleshoot this. In other words, we're first going to find out that it's wrong by typing what we did before. So I'm going to just see if x still has that number in it. Yeah, we're good. And so I'm going to go negative 2 times 3x plus 5 times 2x minus 1 plus 8x, and we get that number we had before, but I'm going to type this one this time, negative 12x squared minus 6x minus 10. And you can see that that's wrong. So now what we have to do is we have to troubleshoot. We have to find out where we made our mistake so we can fix it and get full credit for this problem. So I'm going to come up here and type this one to see if I get what I should have. Negative 2 times 6x squared minus 3x plus 10x minus 5 plus 8x. And that one worked out okay. It's still equivalent to what it should have been. Now I'm going to type the second line. Negative 2 times 6x squared plus 7x minus 5 plus 8x. And that one's still good. So this line was good, this line was good. Now we must have a mistake here. So let's see if it's true. And it doesn't look like I'm doing anything with my left hand here, but it keeps hitting this X key over and over again. And you can see that that's wrong. So the mistake was from here to here, and I can identify it for you here. Negative 2 times negative 5 does not give negative 10. Okay, so next page, we're going to check the canceling here. Let me clear this off, store my value for x, and again, you can type whatever you want. I'm going to type the original problem and the answer to see if this canceling is correct here. So 8x plus 5 all divided by 2 gives this value, and 4x plus 5 gives a different value. So that's wrong, incorrect. And the next problem shows you how to cancel correctly when there's multiple terms in a fraction. When you have more than one term on this numerator or the denominator, you have to cancel all of them at once. So I'm going to divide everything by 3 and see if I get the right answer here. Okay, 1.23, start for x. And let me start with the left-hand side, original problem. Divided by 6. And then I'll type this one. Again, if you got a complicated numerator, you got to put it in parentheses. So all divided by 2, and we get legitimate canceling there. That was checked correctly. Okay, so this student did a lot of work to get from here to here. I'm choosing not to show you all the center steps here, the middle steps. But what I'm going to do is check it. So I'll type 1.23. You guys can use a different number if you prefer. And I'm going to type the original problem. There's that one. And now I'll type this one here, x cubed minus 18x squared minus 11x plus 30. And we know that all that work, and there would have been, I don't know, 4 or 5 lines of work in there, was all done correctly. Okay, I'm going to now switch to a couple of problems that you may not have learned yet. Some of you know about logarithms, many of you don't. So I'm going to have to give you a little bit of information about these, but if you know how to find the logarithm, the common logarithm key, then you can check this problem using the techniques we've just been discussing. All right, so we want to know if the logarithm of the product, here's the logarithm of a product, x times y, is the sum, here's the plus sign, of the logarithms. In other words, when you split a logarithm up that's got a multiplication in its belly, do you use a plus between them? And this seems really strange. We're going to see if it works. Okay, now what you need to know about logarithms here is the numbers inside have to be positive. So x and y have to be positive, and xy also has to be positive, but that'll take care of itself, because if these are both positive numbers, then x times y is also positive. So I'll store what I normally store for x, and then I'm just going to pick another number, 3.29, and store that one for y. Now I have to show you how to find the y. It's the alpha key And right here in green, right above the 1, so touch the 1. Alpha 1 is how you get to y. Okay, let me get that back on screen there. And now it thinks that y values are 3.29. All right, so the common log, and it's right here, right next to the 7, it says log there. The common log of x times y, hit alpha 1, is this amount. And now we're going to take the common log of x, close your parentheses, you have to use these parentheses, plus the common log of the y, alpha 1, and we get the same value. So that's true, and if you memorize that, it'll make you sound really smart. The logarithm of a product is equal to the sum of the logarithms. Okay, let's see if the difference of the logarithm of a difference is the same as the difference of the logarithms. Here's the logarithm of a difference. Let's see if it's the difference of the logarithms. Now, again, we have to have a positive value for both x and y, but we also have to have a positive value for x minus y. Otherwise, this is undefined. You're going to get an error if you don't follow these directions. So we have to have a bigger number minus a smaller number. So when we store the x value, I'm going to do the 1.23 again. I have to pick a smaller positive number for y. So I'm just going to say 87, 0.87. Stored alpha 1 for y. Now I'm going to check out the left-hand side. Common log of x minus alpha 1, and that gives that value. And now I'm going to go common log of x minus the common log of alpha 1y, and you get a different value. So that's false. Okay, so that does it for my examples. And what I'm going to do now is review 5 problems for you to try. And I'm going to have to zoom out a little bit, I think, here. Nope, that doesn't work. Okay, so I'm going to show you the first, I'm going to show you the first 3 here. Okay, and do 6, 7, and 8. And pause the video. After you're done with 6, 7, and 8, then I'm going to reveal their answers, and then I'll show you 9 and 10. Okay, so here's the answers to 6, 7, and 8. And pause the video and do numbers 9 and 10. And here's the answers to 6, 7, 8, 9, and 10. This skill will really help you. It's really worth learning, and it'll seem awkward at first, and there's a lot of typing, but you'll get fast at that. And it's going to improve your grade probably more than anything else I could teach you in a short time.